Good morning, students. Welcome to the organic chemistry class of Alkyl and Aryl Halides. Today we will continue with the elimination reactions of alkyl halides. So first let us understand what is elimination reaction. Now when a nucleophile and an electrophile, generally H+, is removed from two adjacent carbon atoms leading to the formation of a pi bond, then the reaction is known as elimination reaction. Suppose if this one is A, this one is B. I am removing this AB, so what I will get? A double bond is formed. So when these two groups are removed from two adjacent carbon atoms, then the reaction is known as elimination reaction. In class 11, we have already discussed two types of elimination, that is E1 and E2. Let us recapitulate. Now this E1 elimination, this involves how many steps? 2 steps. The first step leads to the formation of a carbocation, and in the second step, the carbocation is attacked by a base which abstracts a beta hydrogen, leading to the formation of an alkene. Now since in E1, carbocation is formed, so tertiary alkyl halides is a very good substrate for E1 reaction. Now in E1 reaction, it is favored by weak base and polar protic solvent. Now E1 reaction is unimolecular. That means the rate equation will involve only the concentration of the substrate. In our case, it will be the concentration of the alkyl halide. Now what about this E2? E2 involve only one step. It is a single step concerted mechanism. Now in E2, since it is single step, it will not involve the formation of any carbocation. Now E2 is favored by strong base. And what about the solvent? In case of E2, the solvent is polar aprotic. Now we will discuss how this elimination reaction is applicable in the chemistry of alkyl halides. So this is ethyl bromide. Now when we heat ethyl bromide with alcoholic potassium hydroxide, then H and Br is removed from these two adjacent carbon. That means HBr is eliminated, leading to the formation of ethylene plus KBr plus HOH, that is water. So this reaction where hydrogen halide is removed from this alkyl halide is known as dehydrohalogenation. Now this dehydrohalogenation of ethyl bromide in the presence of alcoholic KOH is an example of E2 reaction. Let us see the mechanism. This is ethyl bromide. Now, from this alcoholic KOH, we will get OH minus. Now, in elimination reaction, OH minus will act as a base and it will obstruct the beta hydrogen. Now, this carbon which is attached to the halogen is the alpha carbon and this carbon is the beta carbon. So here this hydrogen is beta hydrogen. So this OH minus will obstruct this beta hydrogen. Here a pi bond will be formed and this bond will be broken. So we will get ethylene plus H2O plus KBr. Now, since OH minus is obstructing this beta hydrogen, that means in elimination reaction, this OH minus is acting as a base and not as a nucleophile. In SN2 reaction, OH minus will act as a nucleophile. But in elimination, here since I have shown you E2, so in case of E2, here OH minus is acting as a base and it is obstructing the beta hydrogen. Now see, this is alpha, this is beta. So in this case, HBr, so alpha beta. So HBr is eliminated, that means we can also call this elimination as alpha beta elimination or it is referred to as beta elimination since beta hydrogen is obstructed. So this is E2 mechanism. So it is a single step reaction. We call it as a concerted mechanism. Now we will discuss the dehydrohalogenation of 2-bromobutane. Draw the structure. 1, 2, 3, 4. Br is at carbon number 2 and we have 4 carbon atom. So this is 2-bromobutane. Now this carbon which is attached to Br is the alpha carbon and this is beta carbon. Now what will happen if we heat this 2-bromobutane with alcoholic KOH? Now in this case you will see that we have 3 beta hydrogen here and 2 beta hydrogen at this carbon. Now the structure or the structural environment of this beta hydrogen and this 2 beta hydrogen are not same. Now when you are treating this 2-bromobutane with alcoholic KOH, this KOH or rather OH minus will act as a base and it will obstruct the beta hydrogen. Now suppose if this beta hydrogen is obstructed, then H and Br, these two will be eliminated. So in the first case, I am eliminating this hydrogen and this Br. So what will be the product? C. Here there will be a double bond. This is this hydrogen. This CH2 is untouched and this CH3. Now suppose if this hydrogen and this Br is eliminated, then what will be the product? In that case, this CH3 is intact. So I will write CH3. After this carbon, H. Since we are removing this H and this Br, so a double bond will be formed here. This H will remain and here we will get CH3. So we are getting two products. Now among these two products, one will be the major one. So which one is the major product? This product is the major product. And this one is the minor product. Now what is the UPAC nomenclature of this alkene? This is but-1-ene and this one is but-2-ene. Now why this but-2-ene is a major product? We have already learned said-safe rule. What is the statement of said-safe rule? The more substituted alkene will be the major product. Now, how to check the number of substitution in an alkene? Let us remember this mother compound, that is ethylene. Now, suppose if you compare this but-1-ene with ethylene, say this is the double bond. Here you have how many hydrogen? 1, 2, 3. In ethylene, 1, 2, 3. So the fourth hydrogen is replaced by one alkyl group. Here it is ethyl group. So how many substitution in but-1-ene? But-1-ene is a mono-substituted alkene. So this is mono-substituted. What about but-2-ene? Compare it with the mother compound ethylene. So 1, 2 hydrogen, these 2 hydrogen are intact and these 2 hydrogen are substituted by methyl group. So how many substitution here we have? We have 2 substitution. So but-2-ene is a di-substituted alkene. So but-1-ene is mono-substituted and but-2-ene is di-substituted. So in which case the substitution is more? In case of but-2-ene. So but-2-ene is the said-safe product, that is the more substituted alkene. So in this case but-2-ene is the major product and this is according to which rule? Said-safe rule. Now this but-1-ene and but-2-ene, if I ask you that among but-1-ene and but-2-ene, which one will exhibit geometrical isomerism? But-2-ene will exhibit geometrical isomerism. Because in case of but-2-ene, you will see that the double bond or the terminal carbon attached to the double bond, they are attached to 2 different groups. But in case of but-1-ene, the terminal carbon of the double bond is attached to same group. So but-2-ene will exhibit geometrical isomerism. Once again, I am drawing the structure. This is but-2-ene. That was our major product by the dehydrohalogenation of 2-bromobutane, and this is one, two, three. But-1-ene, see this, check this carbon. This carbon which is attached to the double bond is attached to similar group. So geometrical isomerism is not possible here. But see but-2-ene, this carbon, these 2 groups are different and in this carbon, these 2 groups are different. So this but-2-ene, which is our major product, this is our said-safe product. So this but-2-ene will undergo what type of isomerism? Geometrical isomerism. So we will get cis isomer and trans isomer. Let us see the structure of cis but-2-ene. This is cis but-2-ene and this one is trans, this trans-butene is the more stable alkene. That means trans-butene is the major product. So, when you are dehydrohalogenating 2-bromobutane, you are getting a mixture of but-1-ene and but-2-ene. So, among but-1-ene and but-2-ene, but-2-ene is the major product according to Setsev rule. Now, but-2-ene has how many isomers? 2 isomers. But-2-ene has geometrical isomer, that is the cis form and the trans form. So, among cis-but-2-ene and trans-but-2-ene, which is the most stable alkene, the trans form is the most stable product. Now, suppose if I ask you one question, when you are dehydrohalogenating 2-bromobutane, what will be the major product? Here I am giving you 3 options. This is 2-bromobutane, just now we have drawn. Alcoholic, KOH, heat. So major product, the first option is but-1-ene. The second option is but-2-ene, the cis form, and the third option is but-2-ene, the trans form. Which is the most stable alkene or which is formed as a major product? Here the major product will be the trans-but-2-ene because the trans isomer is more stable than the cis isomer. Let us discuss the dehydrohalogenation of this alkyl halide. Suppose if you heat this alkyl halide with the base methoxide in the presence of methyl alcohol. So now first I will remove this H and this Cl. So the product will be a double bond will be formed here. This is intact. Plus, now suppose I am removing this H and this Cl. Now what will be the product? This CH3 is intact. So here CH3 single bond C. This H, now since H and Cl is removed from this two adjacent carbon, double bond will be formed. Here you have CH3 and here also you have CH3. Now we are getting a mixture of two products. Among this, which one will be the major one? The Setsev product is a major product. Which is the Setsev product? This is the Setsev product. Now here how many substitutions you have? We have here 3 substitutions. So this is a tri-substituted alkene. And here only 1 substitution. So this is a mono-substituted alkene. And we know that the Setsev product, that is the alkene with more substitution or the more substituted alkene, is a major product. So whenever you are treating this alkyl halide with base, which base? Methoxide ion in the presence of methyl alcohol. It can also be ethoxide ion in the presence of ethyl alcohol. So in this case, our major product is the Setsev product. And this is the minor product. Now, if I keep the haloalkenes or the alkyl halides same and I am only changing the base. methoxide here, I will keep this base. This is known as tart butoxide. So tart butoxide ion in the presence of which alcohol? Tertiary butyl alcohol. So if you are heating this compound with what? Tertiary butoxide ion as your base in the presence of tertiary butyl alcohol, then both this product will be formed, but the major product will be different. In this case, the major product will be this product, that is the less substituted alkene is the major product, and the less substituted alkene is known as the Hofmann's product. So the safe product or the more substituted alkene in this case will be the minor product. So as you are changing the base, see the structure of this base, tart butoxide ion, and compare it with your previous base, that is methoxide ion. We can see that this base is sterically crowded. Sterically crowded. Or we can say this is a bulky base. Now we have this beta hydrogens with us and this beta hydrogen. Since the base is bulky, it will not be able to access this beta hydrogen because this place is already a crowded place. So this base has no other option. So what it has to do? It has to snatch this beta hydrogen. And if this beta hydrogen is snatched, then this will be the major product. So in elimination reaction, when the base is a bulky base like tertiary butoxide base, in that case the Hofmann's product is the major product. So this is our elimination reaction. So we have completed nucleophilic substitution reaction, elimination reactions, and reactions of alkyl halides with metals. Next class, we will study the reactions and preparation of aryl halides, that is chlorobenzene. Thank you and have a nice day.